Hey, so a quick review and some examples of what you've learned so far for fluid calculations, mainly flow rates, density, and pressure. Now, we're not dealing with manipulating these. We're only finding flow rate, density, and pressure. We're not finding the other variables when we're going through this. That's something we're going to save for grade 9 and grade 10. So, first of all, for flow rates, we're using the variable for flow rate of just simply FR. Nice and easy to remember, right? Flow rate FR. And we're going to be measuring that in centimeters per second. So it's how many centimeters a fluid travels every second. And typically what we use flow rate for is to compare different fluids and their viscosity. And things that have a higher flow rate are less viscous, right? They have lower viscosity because they're moving faster. So in order for us to find flow rate, all we have to do is take distance and divide it by time. Distance being in centimeters and time we're doing in seconds. For density, we're using this symbol that's called rho, R-H-O, and it's kind of like a weird P. Don't get that confused with pressure, right? I normally draw this starting at the bottom and then kind of curling around like this, so a bit different. So for density, we're either going to measure that in grams per centimeter cubed. So how many grams would a centimeter cubed block be, or grams per milliliter? This is typically the unit we use for a solid. Well, this one is typically what we use for a fluid. Mass is going to be measured in grams normally, and then our volume will either be in centimeters cubed or milliliters. And actually 1 centimeter cube is the same as a milliliter. Those are equivalent units. Then for pressure, we have force divided by area, and this area is like squared area. So this is normally in meters squared. So we have to make sure that if we're using dimensions, we're always using meters for this. And we just take our force in newtons, right, N, and we divide it by our area that the force is being exerted on. And that's in meters squared, and that will give us our pressure in pascals. Now, we've already gone through all these formulas, so this is a quick overview. If you have confusion going through this, I encourage you to go back to the previous videos and watch that. But most of the learning around this is actually going to happen through the examples. So let's get into the examples, try them out, and on your worksheet, I'd like you to copy down the solutions. Focus too on the way that I'm writing it out. I think this problem-solving method of writing out variables, writing out your formula, and showing proper work is incredibly important. In science, there's a big thing around communicating things properly to show your process as you go through so that other people can check your work and make sure that your conclusions are valid. Essentially, it's providing evidence for your final answer. And it's important in all the work that we do in science that involves math or period to show our process, to show how we got there. So here's the question. The box shown below has a mass of 5,000 grams and exerts a force of 4.90 newtons on the table. So I have a mass and I have a force, and then I also have dimensions with which I can find the area from the bottom here, and I can also find the total volume of this. So first of all, what is the pressure between the package and the table? So I know that in order for us to find pressure, I'm going to use the formula P is equal to F divided by A, right? That's just the formula that I have here. Pressure is equal to force divided by area. So now let's actually come up with some numbers for this. For the force, that's easy. It's given to me. It's 4.90 newtons right there in the problem. I'm given that. The area is a bit trickier because for the area, what I have to do is actually take a look at my box in order to figure that out. So for area, I need to take a look at my length and my depth here, okay, or my width and my depth. Basically, I'm looking at this and this. And if I multiply this number and this number together, then that's solving for me the area of the rectangle that's in contact between this table and the box. So my area is going to be 1.0 meters multiplied by 0.5 meters. 1 times 0.5 is of course just going to be 0.50, but now I have the unit of meters squared, which is the unit I'm using for area. So I have my force and I have my area now. So I've got 4.90 newtons divided by 0.50 meters squared. Essentially all I'm doing is doubling it here, so that's going to end up being 9.8, but let me show you on the calculator so you see what's happening. So I'm going 4.90, and then I'm dividing by, 0.50. If I press enter on that, there's my answer, 9.8. My unit for pressure is pascals, so I have 9.8 PA, pascals. Next question, what is the density of this package? Well, my formula for density is that rho symbol. Density is equal to mass divided by my volume. Okay. So volume is going to be a little bit trickier here because if we want to do this in grams per milliliter, or centimeters cubed, which is typically what we're expressing this as, we need to convert all of these dimensions to centimeters. So you should know from previous classes in life that there's 100 centimeters in a meter. So 1 meter, this would be 100 centimeters. 0.50 meters, that's 50 centimeters. And 0.50 meters here is 50 centimeters. So my mass is really easy. That I've just got. It's right in the question. Mass of 5,000 grams. Okay, my volume is trickier because I have to take the width times the depth times the height, and that will give me my volume. So I have 100 centimeters multiplied by 50 centimeters multiplied by 50 centimeters. So my volume is going to be 250,000 here, I believe. 100, wrong place, calculator. 100 times 50 times 50 gives me 250,000 centimeters cubed. So, 250,000 centimeters cubed. So I have then 5,000 grams divided by 250,000 centimeters cubed. So again, I'm dividing, right? That's what this fraction thing means. So top is divided by the bottom. So I have mass divided by volume. And then I can find from there my density. And to find the volume, right, if I have a rectangular prism like I do here, you're just taking all the dimensions, the width, the depth, the height, you're multiplying all those together and you're going to get volume. And because I have centimeters times centimeters times centimeters, that means I have now centimeters cubed, or to the power of 3. And if that doesn't make sense, just know it's centimeters with a little 3 there. So let's take my 5,000. Oh, again, did not click on the right thing. 5,000, and divide it by 250,000. Now again, an answer of 0.02. So my density is 0.02 grams per centimeters cubed. That's it. Those are my final answers. So this is my answer to part A of example 1, and this is my answer to part B of example 1. All right, let's get to the next set of questions. And again, really good for you to copy this down onto your worksheet so you've got it. 500 mils of oil with a mass of 430 grams was accidentally poured onto the driveway. After 2 minutes and 30 seconds, it had made it 85 centimeters down the driveway. Oh no! So what is the flow rate of the oil as it goes down the driveway? Well, we know that flow rate is equal to distance divided by time. So how far it goes divided by how long it took in seconds. So my distance, how far it went, is right here, 85 centimeters down the driveway. So 85 centimeters. You'll hopefully learn over time that the best or easiest way to identify what we have for variables, like which letters we have in this formula, is by knowing the units. So knowing that distance is going to be in centimeters, for example. Time is in seconds. Time is going to be 30 seconds. So flow rate then is going to be 85 centimeters divided by 30 seconds. So I'm going to take my 85 divided by 30, and I get an answer of 2.8333. So let's go with flow rate is equal to 2.8 centimeters per second. Next question, what is the density of this oil? Well, we know that density is found by taking mass and dividing it by volume. So I have a mass of 430 grams. I like writing it over here, keeping track. 430 grams, right? Mass, 430 grams. And after 2 minutes, it had made it 85 centimeters down the driveway. That doesn't help us. What does help us is that it was 500 milliliters of oil. That's my volume. So volume is equal to 500 milliliters. So I have then 430 grams divided by 500 milliliters. So going back to my calculator, 430 divided by 500, and there's my density. It's going to be 0.86 grams per milliliter. So there's my density calculation. There's my answer. Oh, messed that up. Let's try that box again. There we go, that's better. All right, well, that's it. Hopefully those examples helped. If you have any questions, let me know. Have a good rest of your day.